so I'm just going to show the work and then kind of talk through that. For number 6, you had to distribute twice. Make sure you're being careful with your decimals and your signs. Signs is the biggest issue I saw here. Especially when you're multiplying two negatives together, you should end up with something that is positive. So be careful with those. So after distributing, you should have gotten 5.4t plus 9u minus 4u, bringing that down, minus 0.9u plus 3t. And then combine your like terms and you get 8.4t plus 4.1u. Don't forget your variables as well when you're adding things together, multiplying things. Questions on 6? For 7, you have to distribute this -4 to 3 things. Again, be careful with your negatives. Anytime you multiply by another negative, it becomes positive. But when you multiply a negative and a positive, it becomes negative. Up here. Somewhere up here. So, 12a plus 5a minus 20, and then bring down your 4a. Combine all your a's together, you get 21a, and then minus 20. Questions on that one? I'm going to start and walk through number 4 and the answer. If you've got a different answer and you're not seeing where you went wrong, let me know. We can talk through that. For number 4, you have to distribute this 1/4 to both of these fractions. So the -2/3 b would stay the same. You are multiplying across, so 1 times 4 and 4 times 5. And then 1 times, you can make the negative out front or you can put it with one of them, does not matter. So I'm just going to put the negative out front. 1 times 5 will give us 5. 5 times 4 will give us 24. We have like terms, our b's. I can simplify this. I'm going to do that first. If you did do that first and then combine them, you would still get the same answer. But then you would need to simplify. Simplify is what I'm doing. Then to combine these two fractions, they need to have the same denominator. What denominator did we change this to? You guys can say it out loud. 15. You could have chosen something higher, like, what's another number? 30. They would both go into that. Then you would just simplify a little bit more. So we would multiply this by 5, this by 5, this by 3, and this by 3. -10 over 15b plus 3 over 15b. Now they have the same denominator, so combine your b's. -10 plus 3, the denominator does not change, but the numerator does. So -7 over 15 or -7 15, so you can write that either way. You usually won't see the negative in the denominator though. b minus 5/24. Neither of these can be simplified, so that would be our final answer. Who here got that same thing? Few of us. Anyone not get this and aren't sure where they went wrong? Right. Biggest thing with fractions, if you're adding or subtracting, make sure your denominator is the same. Your numerator does not have to be the same, but you're only adding or subtracting the numerator. Multiplying, they do not need to be the same, and you're multiplying directly across. All right. Okay. I'm going to pass out 2 things to you. One, is a faceplate of your calculator. I'm going to tell you some calculator steps and tricks. So if you want to write down those steps and tricks, you can write them down on this. Alright, so as I go through these calculator things, if you want to write them down so that you remember them for the future, you may do that. If you need me to repeat or do whatever again, just let me know. So some important things for you guys. We kind of already talked about how to put in a fraction, but I'm just going to repeat that, so if you want to write that down. Alpha y equals, and number 1 or enter will give you your fraction. Everyone press just the y equals button so that this pops up. It's going to look a little different for you because mine has color. But let's say you press something by accident or you're in another screen. If you want to go back to that main screen, you're going to hit second mode. Second mode will take you back to your home screen. Let's say, you don't have to do this part, but let's say I have a bunch of stuff in here because these calculators get used all day. Sure. I have a bunch of stuff in here. And you just want a clear screen. If you press clear once, it'll go away, but it won't delete anything. You have to actually go back and hit delete in order to delete things, so everything will still be there. But if you did want to completely clear the calculator, you could hit these buttons. So do this with me. Second plus 712. It will completely reset the calculator so that whatever was in there before is gone. You don't have to worry about people storing stuff and your calculator doing weird things, your settings are weird. Any of that happened, just reset the calculator. Second plus 712. If you got something that was a decimal and you wanted it as a fraction or vice versa, if you go into alpha y equals, instead of doing the first one, if you do the fourth one, that will change it from a fraction to a decimal. I'm going to put one in here so you see that. So let's say I just do 8 over 50. I just made up something right. So it's going to give me that as a decimal. But if I want that as a fraction, obviously I just did that. But if I got a decimal and I wanted that as a fraction, I would go up to it, press enter, so that it's now in my new screen, alpha y equals, and go down to 4 or hit 4 and press enter. And it would change that to a simplified version of the fraction or back to the decimal. I could do it again. And it would change it back to the decimal. So F to D changes it back and forth between a fraction and a decimal. So alpha y equals 4. There are multiple ways to get exponents on here. One is the x squared button. So let's say I do 5 and I hit x squared. It will make whatever you put in there squared. If you meant to really make this to the third power, you can scroll back to the left. It'll go up in the exponent piece, and you can override that number to whatever you want. You can also use this, I'm going to call it a caret. So if I use 5, the caret, and then whatever exponent I want, it'll do the same thing. Yes, Alex?
Can you repeat how you got there?
To which one?
To the square.
So the X squared button is right here, so whatever you put in, and then just hit that. If you want to change it, go to the left and highlight it and change whatever that number is.
Okay.
Or you can hit the caret. Anyone see the cube root button? Or the cube root symbol? Alex?
It's one of those cool things about the X squared.
Mm-hmm. So anytime you see anything in blue, in order to hit that, you need second first. If you hit second and then X squared, you'll get your square root. So second, anything in blue is second, anything in green is alpha. However, that's not how you get a cube root. So I'll let you finish writing that down, and then I'll show you. To get a cube root, you have to go into the math button. So underneath alpha, it says math. And then this option right here, number 4, is our cube root. So this is not a square root with a cube outside of it. This is a cube root. So if you were to put in raised to the third power and then a square root, you're going to get something wrong. Make sure you're putting in the cube root, not a square root when it calls for it. Math 4, that's how we got there. When you have a negative that comes first in a problem, whatever, make sure you're hitting this at the bottom and not minus. But let's say you have negative 48 minus something, you would do a negative and then a minus, not a negative and a negative, because then it would think you're multiplying. So be careful with that. Last thing. So this is kind of more advanced than what we will probably do right now, but let's say you want to put something into the calculator, like have it store something for you, like you want X to be 4 for whatever problem you're working on, and you don't want to keep putting in 4. If I wanted to store 4 as X, I would do the following. So do this with me, then you can write it down. 4, this STO right above on, and then to hit X, you could actually do alpha X or hit this button right next to alpha with XT, theta, N, and then enter. It will look like nothing really happened, but now every time I do something with X, so let's say I do 3X, it's going to give me an answer because now that 4 is represented as X. This is another good reason to reset your calculator, because if someone stores something for X and you try to use X, you may get the wrong thing. Okay, so whatever your number is, STO, the X button, which is next to alpha, and then enter. As we go throughout the year, I'll show you more calculator stuff so you can keep adding it to this. Is there anything else we want to know about the calculator as of right now? little notes. Find a page that looks like this. Okay, so we're going to talk about order of operations so that way when we get into evaluating, we understand what we're supposed to do first. You may have learned this a bunch of different ways. Gems, germs, germ dust, PEMDAS, all of those different things. They're all the same thing. So your grouping is going to be your parentheses, your brackets, anything inside that. Sometimes you have multiple, sometimes you may have grouping within grouping. I'm also going to put absolute value bars because that is another form of grouping. And then you have your exponents and radicals. We would do those next. Radicals meaning like your square root, your cube root. And then I'm going to rewrite this here in a second, but when you think of multiplying and dividing, it's not multiplication has to come first, it's whichever comes first, reading left to right. So if division happens to come first as you're reading left to right, that would come first. You would do that first. And then same thing with addition and subtraction. It's whichever comes first, reading left to right. Yes, let me the one I just passed out. The evaluating one. Yeah, that one. If we end up needing to do all of these, let me do this first. So how I usually write this, I use PEMDAS, but I write it like this. To show that multiplication or division doesn't matter which one comes first. That way I'm not stuck on multiplication has to come first. And then same thing with addition and subtraction. If that helps you use it. If we end up doing all of these, that's fine. If we want to just do a couple, that's also fine. Look at these four. Which ones do you feel like you want to do that all together? See it up here. Or maybe aren't sure what's the first step. Which ones would you want to do together? Lily? Number three. This way. Number four. Good on 1 and 2. We want to see 1 and 2. All right, we'll start with 3 and 4. If we need to go to the next one, we can. Okay. So grouping. Do we have any grouping things? We can answer out loud. 2 minus the square root of 16. This wouldn't really count as grouping because there's nothing else to do inside there. So we can focus on this first. So inside this, we can't combine these or simplify this until we get rid of the square root. What would the square root of 16 be? 4. And you guys can say this part out loud until I say otherwise. So 2 minus 4, we have to rewrite everything else and bring it down. And then we could continue with the grouping. 2 minus 4 would give us negative 2. What would our next step be? I feel like you guys said 2 different things. Lily, what were you saying? Yes. Do exponent. Be careful here. So you may know what 4 squared is already. I would suggest using parentheses, especially if you're using the calculator, because of this. If I use parentheses and then I don't, you get 2 different answers. One is right, one is not. The one with parentheses is right. The one without parentheses is wrong. And the reason it does this is because it's really saying -1 times 4 squared. And we want to avoid that. So always use parentheses. That way we can get positive answers when needed. One of these things. There we go. We have -2 plus positive 16 times our -2 multiplied by, or divided by 2. What would we do next? Multiply 16 and -2 to get what? -32. Now here's where our order of operations kind of isn't what we follow, because next it would tell us we have to divide before adding or subtracting, but in this case, because the entire thing is in a division problem, we can't divide this until we've combined this, so we have to do this first and then divide. So -2 minus 32 would give us -34, and when we divide that by 2, we get -17. And then circle your answer at the end. Questions on that one before we continue? Okay. Or number 4, what do we think we would do first? We do have parentheses. We also have absolute value. So we have 2 sets of grouping, and we can kind of do those at the same time. So in order to do this set of parentheses in our numerator, we got to take care of the radical, we got to take care of the exponent. The square root of 36 is 6. And I'm just going to bring down the minus and think about this as 2 to the 3rd. Does anyone know what that would be? 2 to the 3rd. That's like 2 times 2 times 2. You can say that loud. So not 6, that would be 2 times 3, but 8, because 2 times 2 is 4, and then times another 2 is 8. And then, before we do this, does anyone know what the absolute value bars do? Hannah? Yes, does anyone know why? Nature?
It's like with the integer line where it's like, it's actually 5. She's counting how many numbers it took to get there.
Okay. What were you going to say, Lily? Okay. So, yes, in another way to say that, it's like the distance. It's measuring the distance from 0. So, it's counting the distance forward, backward, doesn't matter. So, anytime we have a negative at the end, we make it positive. So, 2 minus 7 would give us what? You can say that loud. Be -5. So we don't change the sign until the very end, until there's nothing else left to do. That's another confusing part about your absolute value as to when to do it. So 2 minus 7, we do that just like normal. We make it -5, and then after that, there's nothing else left for me to do except make it positive. So here, 6 minus 8 will give us -2. I can make this positive now, call that math magic. The absolute value bars are doing its job. This becomes a positive. I no longer need the bars. I don't need to put parentheses in its place because nothing else was next to it. -2 squared would be what? +4. Remember again, be careful with your negatives if you're putting it in your calculator. And then here, if the 4 was instead a 10, we could divide 10 and 5 and then multiply, or multiply and then divide. The order wouldn't matter. But in this case, if we were to try to do that, we would end up with a fraction either way because it doesn't simplify. So here it would be best to just multiply and then see if we can divide. This doesn't simplify, but if you wanted the decimal, you could write that. What is the decimal for this? Either of these would be fine. We have questions on 1 and 2. Do we feel better about our order of operations? Alice? Yeah. All right. So now we're going to switch gears and we're going to go to the evaluating nature. That depends. So if you haven't figured out already, Khan Academy is picky. If they say specifically this answer should be a fraction, then no, it cannot be a decimal. But if they don't say, then it won't matter. So pay attention to the directions because it really depends on what it does. Sorry, before we get into this, does anyone know what the word evaluate means?
Do an analysis.
Okay, what about in math? How would we evaluate in math?
Solve it.
Ish. Usually we try to leave the word solve for like when there's an actual equals something and we're trying to solve for a variable. Simplify would be a good alternative. We are simplifying in a way, yes. Anyone else have something to add to that? How else do we evaluate in math? When you hear the word evaluate, we are going to simplify, but in order to simplify, we have to take whatever is given and substitute or replace variables and numbers. And then simplify. So anytime we do this, we want to use parentheses, especially if we're multiplying. So we're going to take whatever the number is and replace it with the variable wherever you see that. And then simplify. So this simplify would give us what? -38. That would be our answer. We evaluated this when n is -8. I'm going to do one of the fraction problems and then I'm going to let you choose some. With your fractions, I would say leave this negative outside so you're not focusing on which number is negative. And then if I'm putting 12 in, again, use parentheses anytime you are substituting, replacing. If it helps you, write this as a fraction itself so you know you're multiplying directly across. 3 times 12 will give us 36. over 4. And then at the end, always simplify. Fractions, whole numbers, whatever it is, simplify as much as possible. So our final answer here would be, yes. I want you to look at this page, see which ones that maybe you wouldn't know how to start, or it looks complicated, you want to do it together, or anything like that. I'm not going to number them, but you can just tell me what it says, and then we'll go from there. Are there any you see so far that you're not sure what to do? You want to go through those together? Lately, is your hand raised? Yeah.
The very last.
The very last one. That was one I wanted to do also. Any others? If not, I want to at least do this one. So we'll do those two, and if you find any others that you want to go through or had a question about, we can go through those. Okay. Sometimes you'll be evaluating things that have more than one variable, but the process is the same. You're still replacing wherever that variable is. So for this one, -2 times the absolute value, make sure you're on that one, so you're following along. We're going to evaluate twice. I like to make my absolute value bars thicker so I don't confuse it for a 1. Again, put in parentheses wherever you evaluate or replace. What would we do first here? So everything inside, that's like our grouping. So we can multiply 4 and 4 and -3 and 6 at the same time. So 4 times 4 would give us 16. -3 times 6, -18 or -18. Subtract those together, we get -2. Is there anything left to do inside the absolute value bars? No. So because there's no other operations, our math magic happens, our absolute value bars can go away. This will become positive. Because these are next to one another, these are still going to be next to one another multiplying. And then we're going to multiply and add. To get what? 1. Now, with evaluating, you may be doing all the work right and think everything is right. The calculator is a good way to check yourself. So I'm going to put this entire thing in, how we put in our numbers, in the calculator. So I would start off with -2. Absolute value bars, if you go to alpha window, mine has a little bit more than yours does, so that first one, the ABS, that is your absolute value bars. Or yours may actually show the bars, either one. And then we can put in 4 and then parentheses 4, minus, not negative, 3 parentheses 6. Come outside of the absolute value bars, and then plus 5. And we should get the same answer, which is 1. So when you do that, if you get something that you didn't get yourself, so you get a different answer in here, 1, double check that Your signs here are minus, negative at the beginning. All your signs are right. All your parentheses are there. Then double check your own work also. Do we have any questions on that problem? Let's do this last one. For this last problem, one, you have to realize that this is a cube root. You are not doing 2 to the third. So if you need to add in parentheses to separate those, do that. If you're not sure which one it is, ask. And then we're going to put both of these in. 2 times the cube root of 27 minus 3 times 1. Anyone know what the cube root of 27 is? Yeah. You're close. So if we were dividing by 3, it would be 9. But we're thinking of something times itself 3 times. That would give us 27. Three times 3 would be 9. Times 3 again would be 27. So after we have that, we can multiply at the same time. This would become 6, this would become 3, and then we could subtract. And then I'm going to put that in the calculator also to double check ourselves. So 2 times the cube root, remember that's in math. And then number 4. You don't have to put parentheses in the calculator, but if it helps you feel better, go for it. 27 comes out of the cube root minus 3 times 1. And we get 3. It will add in the parentheses if you don't. Are there any other problems on that page we want to go over, had questions about? So there's a few things I want you to do before class ends. On the back, I want you guys to try 13 and 14. When you finish 13 and 14, raise your hand, I'll come check them. After you finish 13 and 14, you have a couple different things. So before you start working, listen. You have a couple different things you could be working on. While you're working, I'm going to be passing out your review for your quiz and test next week. You could start working on that review, finding any questions you have, any questions you want to go over next class, things like that. You have one Khan Academy on evaluating that is due next Friday. So if you've already done the Khan Academy quizzes that are due tomorrow, you could be working on that. If you haven't done the Khan Academy quizzes that are due tomorrow, you could be working on that. So you have a bunch of different things you could be working on. Review, Khan Academy for tomorrow, Khan Academy for next week, or practicing more in your evaluating packet. Okay? So work on those 2. Raise your hand when you're finished, and I'll come check them.